Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and today we have another project that's going to play out in the Bridgeport. We're going to be using a dividing head here, and we have it dialed in. I'm going to bring you in shortly to show you how I got this as close as I'm going to run it. And then we have a tailstock at that end there, and we're going to be setting that up. We're going to be turning about a 24-inch crankshaft in here, and we're going to be spinning it around because we need to put a keyway on two sides. This is a high performance crankshaft, and the customer asked us to put a secondary key 180 degrees off from the key that's existing in the crankshaft. So the crankshaft is still in the box where it's safe, and I'm going to bring you over here, and then we'll carefully bring the crankshaft over when we're ready to put it in, and we'll set that in place here. But I wanted to give you the overall picture. Today we are trying something different as far as videoing over here in the Bridgeport, and that is putting a piece of cardboard on our window there to stop the glare from coming in. It's really competitive to create a decent video on here, and I lose focus sometimes because of the lighting on this section of the shop. So it's also like the same thing when I'm over close to the window in the hydraulic press. It is hard to get shots over there. The best are successful are the ones at night, and the same's been here. But I'm trying this cardboard thing out, and we'll see how it works. Alright, let's go ahead and bring you in closer, and let's take a look at my indicators here and how we've got this set up and running. Alright, you're in close now. You can see the indicator here, and I got the other angle coming into the index head here so you can see how it's sitting on the table. We got one nut back here, and we got two here holding it, and we've dialed it down, and it's clamped down and it's ready to go. So this is the last proving that we're in line, and the head is facing in the direction we want it to in relationship to the table and the mill. And then we're going to go ahead and we're going to grab the little tailstock, and we're going to go ahead and put a center drill. We haven't done it yet, but we're going to center drill or grab a piece with a center drill in there, and we're going to zero in our tailstock to the basic height so that we can shim it up and know where its height, because it's not in line with this. It's a universal tailstock, so it's not set up for this index head on purpose, and we have to make it suit that. All right, so I'm going to run this back to the chuck here and showing you the run out or the alignment of the rod. Okay, and then we'll rotate this around, and that shows you that it's running within a thousandth that way, and we're within a thousandth this way. Alright, now I'm going to go ahead and pull this out of here. We're going to put a center drill in there. We're going to slide the tailstock on over, and let's start setting up the height of that. Then we're going to be mounting it out there, and tape measure here somewhere. Here we go. Alright, the crankshaft is actually 24 inches long, and I don't know if it's going to set in this jaw or this jaw here, but it's going to be somewhere right around in there. So the tailstock's going to get there. Now, of course, we're not going to be able to bring that section of the table over here, so we're probably going to have to tram our head on over to the side and get it into working distance there. All right, but first things first, let's get the crankshaft mounted in here, aligned to the table, set up and ready to cut, and then we'll be bringing our spindle on over to what we need. Okay, we got tailstock over here. We put a center drill right in the end of the shaft here, and we put this back in here so that we'll be able to come up and we can measure. Now we came over, and we want to find out what we're gonna have to shim this thing up. Okay, now this is angled up from the last time we used it, and so what we want to do is we want to loosen this up, because this head is adjustable, so you have a little bit of leeway to go. All right, but with it down and level, we can come on over here, and I'm just going to eyeball center with the shaft there, and we're pretty close to 2 inches. So we need to shim up 2 inches, because we can go a little bit below that, and we can go a little bit above that. It is preferable to go ahead and keep this as level as possible, but you do have a little bit of room to tilt that to make it work. Oh, I'll be darned. Look at that. There's a 2 inch right there. Okay. it is a little bit wider or longer than it is in our root here. So we're going to grab a couple of studs and we're going to set it up in here. And we're going to see if we get enough nut washer contact there, and then we'll be able to go ahead and insert that in there and create a height that we're going to be comfortable with. We'll lock this down and we're going to shim this back there, and it'll give us a start to go ahead and set up our crankshaft in here. Okay, I got my wrench and I got this set up in here, and we got a little bit of side-to-side motion here still, but I eyeballed these straight lines with my bed here, which will be close enough for what we're setting here now, because we're in there, we're not off on one side or the other, we're straight in. Now we still have up and down motion here so that we can gauge this square off of here, and we could do that with a depth mic front and back right here. We could actually see how close that is. Let me grab that tool. Okay, now not to say, hey, okay, eyeball's good, and you know, why isn't eyeball this way? It is good enough. This is just for our own GP here, general knowledge, or JK, right? General knowledge. Okay, we got 69 there, 69 thousandths, and we got excuse me, we have 59 and there's 62. 59, 62. So about 3 thousandths difference right there. It's pretty darn close. I'm not going to bother pitching this up to try to get that other 3 thousandths out of there. And I'm going to go ahead and tighten this one here first. Okay, now our index head can go in and out here to adjust, to take up our length adjustment there. What I want to do is take a Sharpie right now and mark across. Okay, I'm going to take a Sharpie and I'm just going to mark it across right here so that I know how far I had it out. Even though we are pretty straight, it should maintain its straightness. But let's say you were angled up or angled down, you'd want to be pretty close to that same distance in and out, because you would be traveling up or down to a great extent. Whereas we're going to be 24 inches way over there on the other side of the table, and a thou or two is not going to make a difference between that 24 inches and what we're pertaining to. We're going to dial and check the run out of the surfaces that we're going to machine down there to confirm that all of our work that we're doing to set this up is as close as we believe it's going to be. All right, so we're not going to say, okay, we're not going to take it for granted that will be right at the other end, but it's a good place to start. All right, now let's go ahead and we're going to break this loose and we'll get this slid on down. All right, we've had to do a few things off camera to get ready and get this crankshaft setting in here, and at one time we opened this up and we weren't able to get this registered in on this job because this closed up before it got there. So I had to regroup here, and we took out the studs and nuts we had here, and we went in with these low head here so that we could clear. And I mean, we're making it by a 1/4 inch right there on both sides there. So that was our first change out. Then we went to the other end, and our center went right inside the 9/16 hole that's in the end of the crank. And this diameter here was going in, and it was past the center. So the center contact to center contact was not. You would have to have almost a 3/4 inch center to go in and line up with that, the center inside the end of the crankshaft. So we turned an aluminum plug that took and went in and slipped into the bore, and then turned it around and gave us a center drill on the end. Also, we started getting so far out on here, we actually had to go ahead and take a mill clamp, and I have another one up here. I have several of them up here, and I have some of my clamps. I've purposely done that. Put a through hole here and a threaded hole here so that you can bolt this down to the table, and then you can have you can have an extended all thread position point other than your T-nut slots, which I needed to pick up in the middle of this recess or this cavity on the end of the mill table, which your coolant usually runs out on each side, and there's no way to grab a hold of a stud there. So by creating one of your mounts, or taking a flat piece of steel, just like I do my big parallels, drill through holes so that you can bolt them down, and thread holes in them so that you can pick up another. Also too, that is for a stud with a head on it that's domed, and then it can be the low profile support on the end of the clamp. So anyway, these are homemade clamps. Alright, so now we've got the crankshaft in here, and we can rotate the crankshaft around. Now this is what we got. We got one 3/16 key. I believe that's 3/16. We'll measure that. And across from it, we're going to be putting a 1/4 inch key. Okay, I brought over the flange that's going to be going on there so we can start measuring it. And you can see that there's two keyways across from each other. The 1/4 on the far side, and now the 3/16 on the far side. Okay, and they are straight across from each other. This is not uncommon. High performance engines, sometimes a lot of the guys try to pick up extra keyway strength, and with there only being a 3/16 key in there, they want to add a little bit more, and of course this isn't the right size. But I also have made guides for broaching the female keys. Okay, now here's the right broach guide here that lines up and does that size bore. Of course, the last time I used it, the key was a little bit smaller even so than the 3/16. I think it was let's not guess. Okay, it was an 1/8 inch key on one side and probably a 3/16 key on the other side. But it's the same size bore, and it's the same application. Alright, so we know what we got now. We need to go ahead and create a 1/4 inch key for the length of that 180 from the existing key, and that's what we're getting ready to set up. What we're going to do is, we can't run the table all the way over there, so we're going to loosen up our head, and we're going to start swinging our head on over so that we can get in a comfortable position, so that the table's not 100% leaning over that way and the head's not 100% leaning over that way. Alright, I got you in as close as I can, and what we did is we went ahead and checked out our high right here as far as in and out, and then across the diameter that we're going to be machining right there to there. We can't see any definite deflection in there. That's at the end when it hits that little raised area on the shaft, and other than that, so the horizontal plane is great. Okay, now let me go ahead and switch the indicator down onto the side, and we're going to check out side to side. We got this set up now for, so we went up and down until we get right in the middle there. We know we're on the center line as far as up and down. Okay, the indicator does pitch a little bit because of the side to side motion right here on the indicator, but once it starts traveling, it doesn't deviate from our size, it doesn't deviate from its parallelism. So I am real happy that I'm that close to put in a keyway that's going to register this coupling or flange. Alright, we just finished miking up the OD of this at 1 inch 247, and we measured the inside of our flange assembly, and that was 1/246. There's no way that we're going to be able to put these together to test it, but it is the example, and they'll heat and shrink that on there or press it on there, whatever they're going to do to put that flange on there at the time that they need to get it on there. My job is just to do the keyways, And so to start this off, I took and cut and cleaned a nice piece of 3/16 key stock so that I could put it in here. And all I want is just enough so I know it's registering the trueness of that key and giving me an edge out here that I can use to locate it. Alright, I've loosened the flange up slightly in this end, and I'm going to rotate this around to the side. I also have my index head here locked in at 0, and that way when I get ready to, I can do one of two things. Once I set it up, I'll be able to come over and actually cut it on this side, or I can index the thing around 180 and I can cut it on that side there. It's a half a dozen of the other. I might actually just jump up on over on this side here once I know I'm square. Alright, what I did is I took the 1-inch 247 and subtracted that, or divided that by 2. They gave me 623.5, and then I subtracted the half the thickness of the keyway, which is 0.937, and that gave me 0.530. So from the top of this to the key should be 530, and I'm going to go ahead and I'm going to use this cutter to go ahead and come down and touch it. I'm going to eyeball with light underneath here, and then I'm going to come over and then I'm going to gauge it down to here, and I'm going to rotate this upward until I'm against the bottom of this. We're set up. We got the cutter in here. It's tight. We're bringing this down close. We're going to engage our hand wheel here again, and we're going to go ahead and we're going to bring her down until I see that she is touching. Get the right angle of the dangle here. Okay, now I'm going to set this at 0. Alright, bring it up slightly. Okay, we're going to come over here. Now we're going to just make sure that we're out of the way here for coming in or up, and we're going to move over slightly here so we have the big part of the keyway back there, and we're going to go ahead and come down our 530. Okay, there's our 530. Now we're just going to rotate this till that keyway touches, which is right there. We got this in as close as I think we can get it in for our setup here. And what I've done is we just left the key in there. We tapped it in there so we could touch off. I'm using the cutter and coming down, and we set our indicator here at 0. On a touch here. We can repeat that touch within about a half a thousandths each time. So what we do is we go ahead and we rotate this around 180. All right. And we come over to this side, and then we come down, and there again we're right there within that 1 to half a thousandth of matching side to side. We're going to call that 0 or setting equal. All right, so what I'm going to do now is I'm going to go ahead and I'm just going to put it over on the other side because we're happy with that, so that we can watch the cut in on this side here. And we're going to change out to our 1/4" Woodruff key cutter here, and that's what we're gonna mill the slot in there, the keyway. Okay. Now first off, we're going to go ahead and touch. And also, before we get too far here, I want to know exactly the length of our keyway. And we're basically a 1/4 inch shy from that edge there, and a 1/4 inch shy from this edge here. So, and keyway's there. Okay, by eyeball, our keyway is not going to be any longer than that. And that's the outside of the ramp. Alright, we're set up with our 1/4 inch cutter here now. We're coming down. We're going to set that at 0. Right there. Alright, I'm going to come out so we can come on down through the side here. And 623 is right around there. 623 plus that would put the bottom with the split line right now, which looks pretty close. And now we need to add in the other 1/8 of an inch, which is half of the width of this, and that would make it 648. I mean 748. So we add in our gear drive here so that we can bring it down easy. There's 740. 748.5 right there. All right, we should be good to go. Now we want to go ahead and just kind of by eyeball, we should be able to come off the table. That's almost 6 inches dead on, and we know that this should be a 1/16 of an inch under, and or a 32nd of an inch under, because it is a 16 total. And by scale, it does look like it's just under 40 thousandths by the hundredths on here. Okay, I'm happy. We are centered. All right, now we're going to go ahead and we're going to clear some of our area here. You know, we don't want to get chips and stuff spilled on here. I just didn't want to lose anything small in here. And we'll double check our tension on the tables and locking down our system. And we'll come in and we'll grab some cutting oil, because I like to run those cutters slow and with cutting oil. And speaking of slow, let's go ahead and get our speed down in the range right now. Alright, I think we're ready to start. And another way to check this out was, this is almost 1.25 inches, and this is 1/4 inch. This is a 1/2 inch scale. You sight across there, it's close to the top. You sight across here, it's close to there. I mean, you've done all the figuring, you've done all the touch off, you use what you can as far as your instruments, and then it's just time to go for it. All right, so I'm gonna be cranking this by hand, and I'm just gonna try to give you the best view that I possibly can. And I may have to stick my head in there every once in a while to see where I'm coming at, because I want to start at the right position, and I'm going to full depth, and I'm going to go till I get to the other direction. And I'm just going to go ahead and crank the table on over here, because I want to make sure that I have clearance. Okay, that's past my path. I know I'm going to be clearing there, and I think that's going to be great. All right. Get some juice, making sure we're tight on everything there. And I'm gonna touch off first, and then I will from there set my dial. All right. All right, here we go. We're going to go on in. That's pretty tough. Must have been like the surface on there. Just making sure that my ramp isn't up any higher in the back there. We're in 98 thousandths right now. There's 100, 113. Okay, it says 127, 128. We're pretty close to our line there. Okay, I'm going to start feeding it this way here. If we're slightly shy, well, we could go another 16th. Okay, so I'm going to come out. I don't want to just move it because that'll be climb milling. So I'm setting 0 on my X there, and I'm going to come over. I'm going to come over about 50 thousandths. All right. Now I'm going to come back into that depth I was. I'm just trying to get over closer to the start where I wanted to initiate. And we're going to come back into my 127. That's where I was at. Okay. Now I'm just feeding it this way here. Okay, that was my cardboard flying off the back wall there. It's going to make a difference on the lighting probably on the camera, but we're about a 1/4 inch away from our mark. We've moved a total of 3/8 of an inch right now. We're coming up on our mark right now. All right, now we're going to come out. Okay. Now I'm going to raise up. I'm going to set 0 here, man. I don't want it to move anywhere. I want to be able to come down here if I have to again. All right, there we go. Come up out of the way. Take a little air and a rag. All right, we did have to take a second pass on this. We looked at it and we thought it was deeper here than there, but that was a shadow casting. But it made us go get our depth mic, and of course we needed a depth mic anyway to check the final dimension on the depth anyway. But when we came in and touched off, we were on the radius or the diameter of the part, and it takes a certain amount of depth is consumed in getting it down to where it is the 1/4 inch width, which that is 0 as far as your depth of your keyway. So we were 10 to 15 thousandths shy, and we finished the last cut there, and we were able to crank it in, and we're just right around 126 thousandths deep. So we have it to full depth. It looks good. There's hardly any burr on it. We're just going to massage it a little bit with some paper we have and put it in a box, get it ready for the customer to pick up. We are done with the keyways there, and we're happy with that. All right, so we're gonna yank this out, and we did another little job. We're just gonna take you over the lathe before I pull it out, explain what I did. I didn't do any videoing on it just because we are so jammed on time right now. In fact, I had a customer swing by and pick up his job. He called, he brought it in a couple weeks ago, but I'm just getting caught up to jobs that were brought in a month ago. Since my surgery and the pile up that I had of things coming in, when I reopen, I have to go through and I have to take them somewhat of an order. Once in a while, one will skip in a little bit faster, and also once in a while I have marine shafting, and marine shafting trumps everybody's job in here. That's just the way Turn Right Machine Works has been since the day one. So anyway, he had another friend, I guess, that could do it, which I'm surprised he didn't take it to his friend to start with, and have his buddy do. I mean, buddy takes something to buddies, right? All right. Anyhow, I can't get them all, and I felt bad that I couldn't do it in time, or even get started on it, just because of how backed up my log is. All right, let's take a walk over to the lathe here. The flange that goes on the end of the crank, we did a little modification to this aluminum. We tree-panned out clearance for this male protrusion on the hub to go in. It had the boss sticking out that was this diameter, but it didn't. It wouldn't have made it. The face would not have made it up. So we just took a high-speed steel tool, and we ground it and gave it enough relief, and we got in there, and we got a nice tight fit. We like it. It's still enough to where it can rotate around and you can get the right bolts in there, and so this finishes off the job. I didn't do any videoing on this, but I thought you'd like to see at least the next modification that went along with that. So not all the time do we get all the pieces or all the components, and of course we don't have the engine, so I guess we don't have it all again. All right. Here's a close-up look. Hey, until next time, get her done.